Okay, so welcome to this video where we're going to focus on dynamics. That's a new topic. We're going to talk more about dynamics today. So there is no straightforward definition for what a dynamic is, but what you have to know the most is what actually is dynamics comprised of. So here today we're going to focus on dynamics. I'm going to focus on dynamics. Okay, so now what exactly are you supposed to know under dynamics? What you're going to understand is from your secondary education, you've been learning about what forces are all about and the like. So we know that the SI units for force is newtons, and definitely the same newtons, it was named after the scientist who had to discover a lot of things based on the forces. So this same dynamics, we are going to focus on the laws of Newton's. How many laws of Newton's do you know? Actually, we have three laws of Newton's. We have the first law, we call it the first law of motion. In other words, they say law of inertia. That is another name for this law, the first law. The second law, which is second law. So this one, in other ways, you can say it is a law of proportionality, something like that. Then we also have the third law. Third law of motion. This one, they call it a law of reactions or reaction law. Yeah, so these are the things that we are going to focus on in this same video. Now, someone might be wondering to say, what exactly is this same law stating, or what is it that it is saying? And also what this law is saying, including that other law. So basically, mainly the first law, it is rarely being applicable when it comes to calculations, but we are going to focus mainly on these remaining laws, the second and the third law. So here I will state the first law as follows. We learned about this from our secondary education. And how do you state the first law of motion? We are saying an object will remain at rest until an external force has been applied to it. That's what the first law is saying. An object will remain at rest until an external force has been applied to it. Okay, now if you go to the second law, what it states, this law, it only relates the force that you are applying over a given object and what direction is that same force taking the object into. So the second law, states that the applied force on the object is directly proportional to acceleration, and it takes the direction, and the object, here I'll put the object takes the direction of the force. The object takes the direction of the force. What does it mean? Suppose you have, let me use a good example of this calculator. If you're trying to push this calculator forward, you're going to find that the direction in which the calculator is moving, it is the same direction I'm using my force, or I'm applying the force into. So that's what the second law states. So how does it relate to the mass of this same object? How do you relate the second law? I mean, how is the force being related to this one? It has to be related like this. From the secondary level of education, we learned that weight can keep on changing depending on the part where you have been you've placed the object. But as for mass doesn't change. It is constant wherever you can take it to. So same applies even for this one. You are going to understand that if I'm pushing this object, still the mass is going to remain the same. What is going to change is the displacement from where you are taking it from to where you are going to pack it to. So this actually it tells us to say, this one, it says force has to be directly proportional to what? To acceleration, like this, meaning that this mass is our constant thing, and this is the formula that mostly is being applied on different scenarios whenever you're trying to push an object. Now, if you try to go to the third law, what exactly does it state? So you're going to understand that the third law, it relates how objects are being fixed in a position. If you take this object like the way it is here, for it to remain at this given position with reference to where it has been placed, meaning that there is a force that is being applied by the floor, or rather the table which has been which is holding the same object, and also even the same object is also exerting a given force over this. So the upward force and the downward force, they are equal. That's why this object can neither go down nor move upward. This is what we call the third law of motion, because the downward force is equal to the upward force. So I'll try to explain this same law and also give you a simple illustration, or rather a diagram, so that you can understand it fully, to say what exactly does it mean. So I'm saying the third law states that, I'm saying in every reaction, there is an equal but opposite reaction. What does it mean? I'm from explaining from the same illustration, a good illustration for this one. If you place this on the paper, you'll find that the object is not sinking into the paper. Why? Because the force that is being applied by the paper is equal to the weight that this one is having. That's why it is able to fix on its position minus sinking. So here the statement is saying in every reaction there is an equal but opposite reaction, meaning that this one is almost acting on the floor, then the floor is trying to react. And how do you illustrate this one on a simple diagram? This can happen like this. If you place an object on the horizontal surface like this one, what you're going to understand, the object is going to exert a given force downward. We call it a weight force, which has to be equal to what? Mass multiplied by the gravity. And what about the floor? What name is given to the force that is being exerted by or that is being applied by the floor? We call it a normal force, and it has to point vertically upwards, making a 90 degrees angle with the floor. That's why the downward force is equal to the upward force. So even if this object is to move forward, still these two forces are going to be equal. Why? Because the object is not sinking into the floor. Okay, so now just move a step further. What you're going to understand in this case is, if the object which I'm talking about here, if this object was to move, maybe in that given direction, suppose the surface again is rough. The meaning of rough, automatically it means that it is not as smooth as the way we are thinking it to be. So what you're going to understand the most is this: if this floor is rough, as the object is being pulled by a given force here like this one, you're going to understand that this same object is going to experience an opposing force, which is going to be moving. In this case, we call it a friction force. Why? Because the surface is rough. And how is the friction force related to these remaining forces? I know that here we are saying, since the object is just moving on the horizontal without sinking into the bottom part, meaning that the force exerted by the surface has to be equal to the force that the object is exerting on the surface. That's why we are saying the normal force must be equal to the downward force. And what do you write here? You say, if the object is moving, you just write like this. You say summation of forces in the x-axis. This is what we call the x-axis. the summation of forces in the x-axis must be equal to MA. That's what the second law is trying to tell us. This is the application of second law. Second law. Then the issue of the forces in y-axis, the normal force, how is normal force related to the remaining forces? What you're going to understand, you say the summation of forces in y has to be equal to 0. Why? Because we are saying the upward force minus the downward force, they're going to give us 0 because the object is not moving in the y-axis. Alright, so here, if we move, how is the friction force related to these other forces? Even in x-axis, what you're going to understand is this. You say the forward force minus the friction force, you're going to have what? MA. Why do you write it like this? This is due to the fact that we have two types of friction forces. We have the friction force. The first friction force, I'll call it a kinetic friction. We also have the other type of friction force, which is also known as static friction. So the first one is kinetic friction and also static friction as our second type of friction. Now, how is the friction force related to these other forces? Like here, if you take it back, you say that we're having this and that one. How is the friction force related to this? It is related to these remaining forces due to the other component, or rather other important concept. We call it as a coefficient of friction. Okay, so I'm from saying to say friction force is related to the remaining forces, like for normal force, due to the fact of a given important concept which is called coefficient of friction. And how is the same coefficient of friction comes about? The coefficient of friction is given by the letter, we call it mu. Say mu, it has to be equal to, it's just a ratio of that is the friction force and or to the normal force, meaning that the friction force has to be equal to normal multiply, it has to be equal to mu multiplied by the normal force. So if you get back here, we are saying normal force is equal to the downward force, meaning that where there is n here, you can just replace with what? With the weight force. Why? Because in the y-axis we are saying normal force is equal to the downward force. So definitely the formula we are going to be using for friction force, it has to be equal to mu multiplied by the normal force. If this happens on the horizontal surface, normal force always must be equal to mg, which is the weight force. But if it happens like maybe you are moving on a given angle, it becomes something which is different. Now, how would you consider the same scenarios? Friction force is categorized into two. We are saying static friction and kinetic friction, meaning that even when writing the same mu, you can write friction force for K. This has to be equal to mu K multiplied by normal force. In other ways, friction can also be static. You say S, it has to be equal to mu S multiplied by the normal force. Be careful, if this happens on the horizontal surface, we are saying normal force has to be equal to what? It has to be equal to mg. The forces in y must balance. The downward force has to be equal to the force that is being applied by the floor. Suppose it is moving like this one. If it is moving with this force, then there is opposing force, in this case friction. You say F minus friction force, it has to give you what? The acceleration, which is ma, meaning that where there is friction force, if this type of a friction force is static or maybe kinetic, you put the specific expression for static or kinetic friction force where there is that. And remember, the normal force has to be equal to what? Mg, meaning that your formula has to be like this. Say F minus mu, you just put mg where there is normal force, you equate everything to ma. This is one of the formulas that is mostly applicable when it comes to solving questions based on dynamics. Wow, we move to the next step, whereby if it happens like maybe you're moving on an incline, we call it an incline. If you're moving maybe on a slope and the like, how do you calculate for the forces and how forces are being resolved in that case? Now, if we proceed, this can be a horizontal surface. This is my horizontal surface, like the way it is. If this horizontal surface has been raised, you find that an object is at this given point, right? The object, okay, let me do it like this. The object is at this given point. You know that the normal force is, the weight force is pointing downwards, mg. What you're going to understand, if this thing you try to, it is like this, then you try to raise it like this, you make an angle from the horizontal, you bring it at that given point, meaning that this object is going to move together with the surface, but the normal force, I mean the weight force, is going to point downwards, still vertically downwards. Even if you raise it at this given point, you make the object to be at that given part, still this weight force is not changing its direction. It is going to point vertically downwards like the way it is. That's the meaning of weight. Meaning that this now is going to be raised at a given angle also. It is neither parallel nor perpendicular. So what are you supposed to do? You are going to understand that the angle which is going to be at this given part, theta, at which the surface has been raised together with this the object, will be the same angle which is going to be formed where there is what? If in reference to the surface now, which is this one, and the normal force is going to be pointing in that given direction, n. So how do you handle this? Since this one is not parallel, or maybe it is not even perpendicular, you have to resolve it. Remember what we used to do under vectors. So if you are resolving this one, you are going to resolve the angle which is going to be here will be the same angle even which is there. You also put theta. Remember, we are saying the axis cut by the angle must carry cos, sorry. Alright, so if you want to resolve mg, which is the force pointing downwards, we call it a weight force, meaning that this axis is going to carry what? Mg cos theta. Theta, we're talking about this one. You are going to learn more if the reason why we are taking this one to be the same theta as that one. Meaning that if I'm resolving this one, I'll resolve it as follows. I will make this, and also the other component is going to point in this given direction. So here we are going to have the opposite of that, which is mg sine what? Sine theta. Meaning that the forward force in this case, suppose the surface is still, like maybe it is rough. Automatically what you're going to do, you have to forecast that, or you have to say there will be a friction force on the surface. You write friction. Now we are going to have two different forces pointing in the opposite direction to the forward force. Meaning that if this object is moving, what are you supposed to do? You are going to say the forward force minus the backward forces. Why? Because this one is moving in the forward direction, these ones are moving in the opposite direction. Meaning that even the component for mg is going to be part of the opposing force. Alright, now we move. So how would you consider the calculations on this as the incline? Here you say this now is going to be your x-axis, because you have just raised the x-axis which was at this given point, but it's still the object, its weight force is pointing vertically downwards like the way it is here. Meaning that at this given point now, this is going to be my x, and this is going to be in the what? In the y-axis. So since it is moving, still the normal force is going to be equal to the downward force, which is going to be this one now, and not this one. Why? Because in the y-axis we have two forces, of which the object is not sinking in the what? Into the incline, or maybe it is moving up. Then you say the summation of forces in y must be equal to 0. Why do we write equal to 0? It's because the object is not moving. So you write like this. You say normal force in this case is going to be equal to what? Mg cos theta. Then the forces in the x-axis, you write like this. Forces in the x-axis must be equal to ma. Why? Because this thing is accelerating. That's why we write it like that. So you are going to find that it will be force, which is the forward force, minus the backward forces. We have friction force and also that one. If friction force is not there, automatically you only have this one. So in this case, we assume that friction force is there. You say again minus mg cos, sine theta. It has to be equal to what? Ma. So we have a lot of scenarios under dynamics. We can have the horizontal scenario. We can also have incline scenario, and also we are going to look at what we call the Atwood machines. So for Atwood machines, including the other type of scenario, we're going to talk about it in the next video. As for this one, I'll just give you an example on how to handle a question if it has come with the friction force. So we look at the example right now. But before I give you an example, I would like to conclude it as follows. We are going to have two different surfaces. We have the inclined surface, which is for this type, and also the flat surface. Here we are saying the normal force has to be equal to the weight force. Why? Because the object, in y-axis, the object is not moving in y-axis. For this one, the weight force is pointing vertically downward, still like the way this one is. You are going to put weight. You have to resolve, okay, here you can say this is my angle. You have to resolve this one into its components. We're going to have something like this. Then this is going to be mg, because the angle which is here is just one and the same like the angle which is going to be there. So here you write, okay, you write w cos theta, and there you write w sin theta. Remember, the normal force always has to be perpendicular to the surface on which the object has been placed. It will point in that given direction. And then friction force, we have two types. We have kinetic friction, which is going to be equal to mu k normal. Then also static friction, mu s has to be equal to, fs has to be equal to mu s normal. So if this object is moving like this direction, its acceleration is pointing in that given direction. If this one is moving in that direction, acceleration has to be pointing like that. So we solve a question now so that we can understand it fully, how friction force is related to the forward force and other forces. Alright, so our example goes like this. We can say a 2 kg box is pushed by a 50 newtons force, full stop, if the surface is flat. Then we are saying, and the kinetic and the coefficient of kinetic friction is 0.2. So we can just say draw a free body diagram, full stop. That is question A. Then for question B, I would like to say calculate the acceleration of the box. So first of all, before you even start solving this question, what you should focus on is to draw a free body diagram. What is the meaning of a free body diagram? You draw how the diagram is going to look, and also you even point out the forces that are acting on that given diagram. The keyword here is this: the coefficient of kinetic friction, meaning that friction force there is there. Its mu has to be in a form of kinetic. So we try to draw the free body diagram here now. Alright, so if you want to draw a free body diagram for this one, you are going to understand that this is going to be my horizontal surface, and the object here, it is having a weight of, it is having a mass of 2 kg. So since this is having a mass of that, and it is resting on the, it is moving on the horizontal surface, the weight is going to point like this, which is mg. And then the normal force is going to point in like that. So what you're going to understand here the most is, since we are pushing this object forward like this one with a force of 50 newtons, remember the friction force has to be moving in the opposite direction. So it is going to point in the opposite direction. You say friction force. What else is it missing in this case? We don't have anything missing because we have all the forces that acts on this given object. Alright, now we proceed. We move a step forward. What you're going to understand the most now in this case is the friction forces are moving in the opposite direction. So I've just tried to draw these forces like this, but I can draw them in a proper way to show how they are acting on the object. We have this object having this force which is moving in this direction, 50 newtons. We also have friction force pointing in the opposite. We also have mg, and also we have the normal force pointing upwards. The reason being we're having these two forces because the object is not moving in the y-axis. Hence, these forces, they are what? They are balanced. So what are you supposed to do now to solve this same question? You just focus on the part in which the direction is being taken into, or maybe in which the object is moving. Its acceleration is pointing in that given path. Okay, so since it is pointing in that given direction, what are you supposed to do? You just tell them to say the summation of forces in x must be equal to the acceleration. We have two different forces in the x-axis. This is my x-axis. So we are going to write it like this. You say force minus friction, it has to be equal to what? ma. That will be the first equation which you have to know always. You come to this given part in y-axis. We are saying the summation of forces in the y has to be equal to 0. Why? Because the object is not moving in the y-axis. And what are we going to get here? We are going to get n minus mg. It has to give us 0. The reason being we are saying it has to be minus because the other one is moving up and the other one is trying to oppose, moving downwards. So we are going to have normal force has to be equal to mg. That is the relationship which is there. You come back to this one. What formula did we give you? I gave you last time when I said you have to use these formulas for friction force. We said friction force, it must be equal to what? Mu multiplied by the normal force. Due to that kind of definition which I gave you earlier, then if you try to look at this system, it is moving, meaning that you're going to have kinetic friction. Even this one are going to have coefficient of kinetic friction like that. Okay, we proceed. Now, getting back to the formula itself, if we continue, we are going to understand that friction force is equal to that, meaning that where there is this, I can just replace with that one. But remember, we are having this, which is the what? The force in this case is 50 newtons. We also have the mass given there, meaning that I can replace everything and I'll be able to do it to find the acceleration of this object. So this becomes my first question, whereby they're saying draw the free body diagram. This becomes the free body diagram. We don't draw a free body diagram like this. This was just a simple illustration for us to understand what we are trying to talk about. We come back to this. If you come back to that part, you are going to understand that this is going to be as follows. We are having friction, force minus friction, which is now going to be replaced by mu k multiplied by mg as the normal force. You say equal to m multiplied by a. We have this one, which is 50 minus, what is my mu? We are saying it has to be 0.2 multiplied by this one. We are saying it has to be 2. Remember here we are no longer using g, which is gravitational force or gravitational acceleration, as 10. We take this one to be definitely it has to be what? It has to be 9.8. 9.8, you equate everything to 2 multiplied by acceleration. You divide. You also divide. What answer are you going to get if you try to calculate in that same case? So we are having 50. So you say minus, open bracket, 2 multiplied by 0.2 multiplied by 9.8. I close. So I'll get that. Now say divide this by 2. So we are having an acceleration. You cancel this. The acceleration in this case is getting is being gotten as 23.04 meters per second square. Keep on waiting for more videos on this same topic. Thank you for watching.